Okay, 5.4 is mutually exclusive events. So if you are mutually exclusive, it means you don't have any overlap. So your probabilities of A or B happening is just the probability of A plus the probability of B. So the next one, non-mutually exclusive events, there's somewhere along the line that you overlap. So an example like here would be probability of getting a red card or a black card in a deck. Here you could say the probability of getting a red card or a face card, because now you can see that you would have some red face cards that would belong to both. Okay, so the probability would be A, probability of A plus probability of B, subtract the probability of both of them. Okay, so this first one, if you roll a sum greater than 8 or a multiple of 5 when rolling 2 dice, you get a bonus of 100 points in the game. What is the probability of getting the bonus? Okay, so I've done this already. So if you roll 2 dice, so 1 through 6, here's your possible sums that you could get. Okay, so the sum of something greater than 8 Okay, so there's your possibilities for that. So 4, 5, 6, 7, 8, 9, 10 out of 36 sums. And multiples of 5. So 4, 5, 6, 7. So the probability of getting something over 8 plus the probability of a multiple of 5. But then you have to consider subtracting the overlap. So what did you count twice? Those 3. So you're going to have to subtract 3. So that ends up being 14 out of 36. Okay, the results of a survey are the following in a newspaper. 62% of people skip breakfast, 24% skip lunch, and 22% eat both breakfast and lunch. Are they mutually exclusive? Determine the probability that a randomly selected student skips breakfast but not lunch. Determine the probability that a randomly selected student skips at least one breakfast or lunch. Okay. So, to be mutually exclusive, your probability of your events happening plus the probability of them not happening should total 1. Does that make sense? Okay, just like how we've done all those, like at least, in the last one we did at least 1 boy, so we did 1 minus no boys, because those should add up to 1. Okay, so probability of the events happening is 108. So this is not mutually exclusive. Okay. So let's draw a Venn diagram. So this is the universe, so this would be skip breakfast and skip lunch. How many skip both? Okay, so there's 22 people, or percent, that eat both. Okay, so they don't belong in any of those skipping. Okay, so the 22 out there. So that leaves us 100% minus 22% leaves us with 78% that we're going to put into these spots. Okay, so now 62 plus 24 equals 86%. And so this, there's 86. We want 78% in there though. So this is too much. So how much would we put in the overlap? So we're going to take that, subtract 78, which leaves 8%. So 8% goes into the overlap. Okay, so now in the skip breakfast, there's 62%. So 62 minus 8 is 54%. So 62 minus 8 is 54. And in the skip lunch, I want 24. So 24 minus that overlap of 8 is 16. So now you could see that all of those should add up to 100. Okay, so we've decided they aren't mutually exclusive. B, determine the probability that a randomly selected student skips breakfast but not lunch. So that should be 54% right here. You can see just 54 is in this alone without being in that group. Determine the probability the randomly selected student skips at least one of breakfast or lunch. Okay, so that would be 78%. Somewhere in here, and it could be anywhere in there. A mother buys a new washer and dryer set for $2,500 with a 1-year warranty. She can buy a 3-year extended warranty for $450. She researches the repair statistics and finds this data. So we're going to try to figure out if she wants to or should buy the extended warranty. So appliances, this is the probability repair within the extended warranty. And then the average cost. Okay, so we're going to draw a Venn diagram. Okay, so 3% of people repaired both. 22% repaired a washer along the line, so that leaves us with 19 in there. So you can see that the washer bubble adds up to 22. And 13% would leave us with 10% here. So what does that leave us with? So this all adds up to 32%. So 68% did not repair. Okay, so the average cost to repair a washer was $400. So there's a 19% chance that you would pay $400. There's a 10% chance you would pay $300. And there's a 3% chance you would pay $700. So she can buy the 3-year warranty for $450. So this is really the only thing that would say she would have a reason to pay for that, because that's the only cost that ended up over $450. So I would say don't buy. There's only a 3% chance that you would have a cost over $450. Okay, last one. A car manufacturer keeps a database of all the cars that are available for sale at the dealership in Western Canada. For Model A, the database reports that 43% have heated leather seats, 36 sunroof, and 49 have neither. Determine the probability of a Model A car at a dealership having both leather and sunroof. Okay. So heated leather seats, and then we have a sunroof. And then outside those bubbles would be neither. Okay, so 49% have neither. So what does that leave us with inside the bubbles? We need 51%. Okay, so 43 plus 36% equals 79%. That's over top of my 51. So what's in the overlap? (79 minus 51), so 28% will have both. Okay, so in the heated leather seats, I need 43. So that leaves me with 15% here. That makes 43. And I need 36 here, so I need 8 more percent with just that. Determine the probability of a Model A car at the dealership having both. So the answer to that would be 28% chance that they would have both.